Well, guys, today we will do some more problems from SC Verma, and we have done from question number 1 to 5. And let us see what is question number 6. So, question number 6 is on your screen, which says that the equation of the motion of a particle is started at t is equal to 0 is given by x is equal to 5 sine 20 t plus pi by 3. So x is equal to 5 sine 20t plus, this is the expression for the position of the particle where x is in centimeter and t is in seconds. So x is in centimeter and t is in seconds. So this is our question. Let us see what they are asking. They are asking, when does the particle first come to rest? Then when does the particle first have zero acceleration? And when does the particle first have maximum speed? So one by one we will see. But before that, we will analyze this expression. What is this expression? This is an equation of a simple harmonic motion. So what is basically, let us see, your simple harmonic motion, generally it is like this. Let us see about this. When this is, what will be the waveform for this equation? Correct? So suppose t is equal to 0, what will happen? X will be equal to 5 sine 20 into 0 plus pi by 3, and this will come out as 5 sine pi by 3. Pi by 3, we know the value, that is root 3 by 2, that is 5 root 3 by 2, or you can say 2.5 into root 3. So at t is equal to 0, so that means this equation, it is 2.5 root 3. This is x, this is t. So at this point, it is cutting at t is equal to 0. Now let us see this equation where it will cut this t-axis. So where at t-axis x will be 0. So if we put 0 is equal to 5 sine 20t plus pi by 3. Then what is this? Sine 20t plus pi by 3. This must be equal to sine 0, means sine 0, or you can, from this you can get t will be nothing but minus pi by 60. So at t is equal to minus pi by 60, this wave will cut at the t-axis. That means minus pi by 60, it will be Suppose this is the point minus pi by 6. So our equation is basically it's coming like this. Let us draw it. Suppose we take pi by 60 here. What will happen? But now this is basically less than 5. So this will go further and like that this will. This is how will be the waveform for this expression. Of course, this is your phi. That is the amplitude of this simple harmonic motion. We would like to see that is what is the time period. Time period is nothing but 2 pi by omega and 2 pi by 20 because this is the omega and this is nothing but pi by 10. Correct. Now let us see. This is pi by 10. Oh, that means the full for one cycle it is taking pi by 10. Correct. That means this is if we start from here. So from here to here, how much time it will take? T pi by 40. From here to here, again pi by 40. Or you can say from here it will take pi by 40. From here it will take 2 pi by 40. And this 3 pi by 40. And this will be, I think, 4 pi by 40. And of course, this is nothing but pi by 10. So if we, this distance, if we see this distance, this is basically nothing but pi by 40. I hope this is clear. With this time period, you can denote this waveform at different time periods. So, what is this distance? Let us see what they have asked. They have asked when the particle first come to rest. A part. When the particle is first coming to rest, particle will come to rest when it is at the extreme position. So particle is starting from here, correct? And this is the extreme position. It is first time it is coming to rest at this position. And this part is pi by 60 and the whole part is basically pi by 40. So what is this part? This time will be nothing but minus pi by 60 plus pi by 40 and this will give you pi by 120. Correct? So at time t, that is pi by 120. What is this? This is this time is basically pi by 120. At this, after this, because we are taking t as 0 here, so after pi by 20, it will come to first. It will come to rest because this will be at the extreme position. Now, next part is, what is the next part? Next part is basically it is saying when the particle will have first have zero acceleration. Zero acceleration. When it will have zero acceleration? Zero acceleration will be when acceleration is what? Acceleration is basically omega square x. Correct? So when x is 0, your acceleration will be 0. When x is 0, x is coming 0 at this point, but this is not, this is beyond, before t is equal to 0. So what is the next point? This is the point where it is coming, acceleration is coming as, or x is coming as 0. So what will be this distance? This we know pi by 120, and this we know pi by 40. Then what is this? This t will be pi by 120 plus pi by 40 will be nothing but 120. This will be 1 plus 3 pi, or this will be pi by 30. So at this time, of course this will be in seconds. This will also be in seconds. So unit का थोड़ा ध्यान रखने का है. So acceleration for the first time, acceleration will be 0 at t is equal to pi by 30. Now let us see the third part, that when it will have, first have maximum speed. So where it will have maximum speed? It will have maximum speed at the midpoint. Correct? So where it will have, from the graph you can tell where the maximum speed will be. Of course maximum speed will be here. So suppose if this is O, this is A, and this is B. So at point B we have acceleration as 0, and at point B we have maximum speed also, because particle is crossing from the midpoint. Correct? So at this point we have already found out what is the basically t, like in this case t is equal to pi by 120 plus pi by 40, and this will be nothing but pi by. So this is the solution of question number 6. With this philosophy, you can easily solve this question, and even if whatever is given, even if some more things are asked, if you have made this graph, then you can never go wrong, because everything is visible from this, where the particle is on the extreme position, like this, where the particle is crossing the midpoint, then again extreme position, then like that you can solve any type of queries regarding this question. So this is what we have to understand. It's not only what is given in the question we have to solve. We have to understand the things. We have to understand the question fully with the basics, and if there are other more things have been asked, you should be able to solve that. That is the philosophy behind it. So now we will go to the next question, question number 7. Well, guys, now we will see what is question number 7. If you have understood the question number 6 the way I have given you the solution, then this question number 7 is just halwa for you. Let us see what question number 7 is saying. Consider a particle moving in simple harmonic motion according to the equation. Let us write the equation first. X is equal to 2 cos 50 plus this is your equation where x is in centimeter and t is in second. The motion is started at t is equal to 0. Now they are asking again the same questions which they asked in the question number 6. That is, when does the particle come to rest for the first time? When does the acceleration have its maximum magnitude for the first time? When does the particle come to rest for this first time? So first of all, let us curate our graph according to this equation. Now here actually it is given tan inverse 0.75. Let us simplify this. Basically tan 0.643. Of course this is in radian. This gives you, so we can simplify this equation as correct. Again, for making the graph, we require certain things. Let us see what is the time period. Two pi by omega, and that is 2 pi by, what is omega? This, that is pi by 25. Now let us see at t is equal to 0, or where this thing will cut the t-axis. So that means x must be 0. If we put x is equal to 0, then what is this? This will be cos 50 pi t plus 0.4643. This will be equal to cos, where is cos 0? Cos 0 is basically at pi by 2. So what will be t? If you solve this, you can write it like this also. If you solve this, this will come as 0.006. You can solve it from your computer calculator. So this is the time at which the graph will cut the t-axis. Correct? So this is a cost curve basically. this will be like this. It is positive. T is positive here. That means this is cutting at this. And what is this? This is T. This is X. This is 0. Suppose this is point A and this is coming as. Correct? Time period we have found out. Time period is basically, time period is basically, this is pi, because omega is this thing. So this is nothing but 1 by 25. Correct? That means for one cycle, it is taking a time period of 1 by 25 seconds. So we divide these things because we know what is this. What will be this? This is 1 by 25. Of course, if you divide it, what is this? T by 4, or we can write it as 1 by 100, or we can write it as 0.01. Likewise, this is also 0.01. Likewise, this is also 0.01. Likewise, this is also. I hope in understanding this problem or how we are writing, it is just T by 4, T by 4, T by 4 we are writing. So please don't confuse yourself. So this is the graph we have curated. With this graph you can answer all your questions. Correct? Now what is the first part? First part is, when does the particle come to rest for the first time? Now you know when does the particle will come to rest? Of course it will at the extreme position. And where it is coming from this? What is the first extreme position it is achieving? That is this position, that is OA. And what is this time? This time is nothing but 0.006 plus 0.01, and this will be nothing but 0.016 seconds. So this is your answer A. Simple. Now next, when does the acceleration have its maximum magnitude for the first time? Acceleration, you know, what is this? Acceleration A omega square x. Acceleration will be maximum when x will be maximum. Correct? So means acceleration will be maximum at the extreme position. So extreme position, what is the extreme position here? First time when it is achieving the extreme position, again this thing, it is coming at A. This is the extreme position, this is the maximum amplitude. So again answer B is same. Now let us see what is the third part. When does the particle come to rest for the second time? This is what in the last question we told you, if you can curate this kind of graph, you can answer n number of questions. So just see when the particle is coming to rest for the first time. First time it is coming at A, but because at the extreme position it will be at rest. But when the particle is coming For the second time, this is going like this. Now at second time, it is coming at point B at rest. So what is the time period? 0.006 plus 0.01 plus 0.01 plus 0.01. This will give you nothing but 0.036. Correct? I hope you understood this. Okay? Anything you can be asked, anything you can answer from this graph, if you can curate it like this, just whatever problems are there, try to understand the problem, and your problem solving should also be general in nature. It is not, should be very specific that this is the method, we have to apply this method only. It is not like that. Okay, because whatever questions are there, they may not be asked, but they related to that, something more can be asked, something extra can be asked. You should be prepared for that. So I hope you understood this question. If you have any doubt, you can comment. Okay, and let us go to the now question number 8. We will go through so you have seen question number 6, question number 7 today, and now we will go to question number 8. Let us read out what is question number 8. That is, consider a simple harmonic motion of time period t. Calculate the time taken for the displacement to change value from half the amplitude to the amplitude. That means full amplitude, of course. Correct? So we have to find out. Suppose this is your simple harmonic motion. This is time period is basically t. So naturally it will have t by 4. Here it will have t by 2. It will have 3 t by 4, and here. If you measure the distance from this is your t, your x. Correct? So this is what. Now they are asking amplitude. Amplitude is this. What is this value? This is A. And suppose this is your A by 2. And this point is A and this point. So they are asking the time taken from A to B. This we have to find out. We can assume this type of graph is there. We can assume that x is A sine omega t. Simple, because we can take phase constant also, but that will cancel out. So let us take a simple equation. Now suppose when your this thing x is A by 2 or x A, suppose from 0 to A it takes t1 second. Means what is this? X A nothing but A by 2, this distance, and the sine omega t1 is nothing but sine. This is 1 by 2. 1 by 2 means it will be pi by sine 30 degree pi by 6. That means omega t1 is nothing but pi by 6, or t1 will be nothing but your pi by 6 omega, or pi by 6 into 2 pi divided 2 pi by t, because omega you know. So that means what is it is giving? It is giving us t 1 by 12. Likewise, at b, what will happen? From, if we take a time taken from this 0, it is from 0 to b. How much time this wave is taking? This will be nothing but, suppose this is, we assume as t2. So and this will be sine omega t2 is nothing but 1, so that means sine pi by 2, or t2 will be nothing but omega t2 will be equal to pi by 2, or pi by 2 into omega is 2 pi by t, and this is nothing but t by 4. That means your wave, the simple harmonic motion, the position from O to A, it is taking t by 12, and from O to B, it is taking t by 4. So what will be the time it will take from A to B? That will be nothing but t2 minus t1 and 1 by, t by 4 minus t by 12. And if you calculate this, this will come as t by 6. So this is your answer. So your particle will take t by 6, in t by 6 time. It will take from A to B, where A, at this point at A, the amplitude is A by 2, and at this point B, amplitude is the full amplitude. So this is the solution of question number 8. Now we will see what is question number 9. Question number 9 says the pendulum of a clock is replaced by a spring mass system with a spring having spring constant 0.1 Newton per meter. Okay. What mass should be attached to the spring? Correct. So here two or three things we are important. What is the spring constant? It is given. Correct. And pendulum of a clock. Pendulum of a clock. What is the time period of a pendulum of a clock? Pendulum, you see, it makes to and fro motion in the clock. When it goes like this, 1 second, then another second, it goes like this. That means in completing one cycle, suppose when it goes like this, then 1 second, in 1 second, and when it comes to this, 1 second and 1 second. That means for one cycle it takes t, that is the time period, it is 2 seconds. This is what we have to understand in this question. If you are not able to understand what is pendulum now, because time period is not given, that you have to think, correct? So pendulum of a clock is replaced by a spring coil. Now it is replaced by a spring constant, spring mass system. Okay, so if it is replaced by a spring mass system like this, or it can be like this, then time period is not going to change, because here time period 2 seconds, then of course here also the time period will be same. So that means your time period is, now you know what is a time period in terms of m and k, that is t is nothing but 2 pi root m by k. If it is a spring mass system, then time period is given by this equation. You can see our previous lectures how this has come. So now it is very simple. You have to find out m. M is what? M will be nothing but it will be t square upon 4 pi square into k. Correct? This will be nothing but 2 square upon 4 pi square into k. K, you know, it is given as 0.1. Correct? And you just solve it. This will give you the mass of the spring mass system which has same time period. So this is the solution of the, you can simplify this with your calculator. So this is the solution of question number 9. It's a very simple question. Now we will see question number 10. Question number 10 is basically a block suspended from a vertical spring is in equilibrium so that the extension of the spring equals the length of the equivalent simple pendulum, that is a pendulum having frequency same as that of block. Okay, correct. Now here this is M and extension is X, and what about F? F is nothing but your K into X. K is the spring constant of the spring. Correct? And of course, what is this M? What is the downward force? That will be mg, and this will be, suppose if you press it by X, then that will be your restoring force also. Now another thing is simple pendulum. Simple pendulum we generally denote by this. It goes like this. Okay, and the hair length is this. This is your M. Correct? So we have derived these things in our previous lectures. What will be the frequency of this? Frequency, angular frequency will be nothing but your G by L, and here what is frequency? Here it will be basically K by M. Now in this question, they have a pendulum having frequency same as that of block. That means these two frequencies are same. Or we can write it as G upon L upon, or L is nothing but mg upon, and this mg is what? Mg is basically force. This means L upon L is equal to. This is what they are asking. Show that the extension of the spring, that is x, is equal to the length of a equivalent simple pendulum. Length of a equivalent simple pendulum is basically L. So this is what we have to prove. L is equal to x, and here L is equal to x. So this is how you can prove. It was a very simple question. So, and this is the solution of question number 10. So now in the next lecture we are going to take further problems from S.C. Verma book, from the simple harmonic motion, like question number 11, 12 and further so on. We are going to solve each and every problem in our lectures. If you like these videos, please do subscribe my channel, and if you subscribe it, then of course this will give me further motivation for uploading more and more lectures of this kind. So, and that will be helpful to understand the subject. So thank you very much for the today.